Absolute value part 1, the introduction. Absolute value is indicated by the vertical line on either side of the number, and what it means is that it's the non-negative value of a number. In other words, the distance of the number from 0 on the number line. It ignores the negative aspect of the number. There's an example. Absolute value of negative 3 becomes 3. Absolute value of 6 stays as 6. Absolute value also counts as a bracket. So simplify inside the bracket first, and then continue. There's the negative outside the absolute value, which is not affected, but the negative inside the absolute value is dropped. This is the previous example, but now it's in another absolute value sign, the red one. Notice? So we simplify inside the outside absolute value sign first, and then it continues one step. Multiplication of absolute values, well, it's the same as multiplying brackets. In fact, the only difference is the effect that the absolute value has. Here are some examples for you to do. Pause and try them. Notice that in this case the negative is not being squared. It's the negative of a square, therefore negative 9. Here the negative is being squared. Here's that case again. It's a negative of a square. Many make the error of thinking that becomes positive 81. It is not the same as something like that where the negative is inside the bracket. Let's look at the definition of absolute value. Here we are. What it says is that the absolute value of a number, the number is not affected if the number is greater than or equal to 0. If the number is less than 0, then its sign is changed, i.e. changes the sign. Strictly speaking, of course, we must remember that these lines on either side will make a bracket as well, so we could see the definition as reading like that. Here's an example of what that means. If you have the absolute value of a minus b, then if a minus b is greater than 0, then we can just write a minus b. But if a minus b is less than 0, we have a negative of, and the absolute value must become a bracket. There's the sign change. Then that simplifies. Notice I made it if a greater than or equal to b, and this one if a greater than or equal to b, and I've taken away the brackets. Here are some examples. In this first case, x greater than 2 means that x minus 1 will always be positive. So therefore it's just x minus 1. X less than 4 means that the contents of this absolute value sign, x minus 5, will always be negative. Thus notice the change, negative, and then with a bracket. And it invokes that part of the definition. In this next case, if x is greater than or equal to 1, then both of these will be positive. So therefore, we just have the brackets, simplifies. Now in this case here, we are not given a condition, which means you've got to bring up the conditions. There they are, you have to bring up the conditions. If 2x minus 3 is greater than or equal to 0, if 2x minus 3 is less than 0. So here we are. 2x minus 3 if 2x minus 3 is greater than or equal to 0. 2x minus 3 could be positive, and I'm going to simplify that to x greater than or equal to 3 over 2. Now, of course, 2x minus 3 could be negative. So therefore, its sign needs changing, so I put negative and the 2x minus 3 in brackets. If 2x minus 3 is less than 0. Simplifying, and I'll always work that out to be what x must be. In this next case, we have what we could call two critical values. Two values where an absolute value has a 0, when x is negative 4 or when x is 3. So we're actually looking at three regions: x less than negative 4, x between negative 4 and 3, and then x greater than or equal to 3. So the first case, less than negative 4, both of these will be negative, which means we'll have a negative in front there, and we'll have a negative, which means a sign change here. It becomes positive. Between the two, this one now is going to be positive. Anything between negative 4 and 3 will make this one positive, but that one will still be negative. So this one stays as is, and this one still has a sign change. Finally, greater than or equal to 3, both of them will be positive, so they stay as is without any effect of the absolute value sign other than brackets. And of course that simplifies to that. Notice I've taken away the brackets and they're like terms, and we add like terms. Here are some examples for you to try. Pause, try them yourself, and then the answers will follow. Notice this one's quite a bit tricky because it's 5 minus x. So if x is greater than 5, 5 minus x is going to be negative. Therefore, note the sign change. And the opposite effect here too. This one here, yes, have a look. X less than negative 3. This will always be negative, but that will always be positive. So this has a sign change, that doesn't. Notice this one here, you need to be careful, because when this is positive, 7 minus 2x is greater than or equal to 3, and we don't have any sign change. When 7 minus 2x is less than 0, we have sign change. Now when we simplify these, we end up with a bit of an adjustment. Think of it this way. Let's take the minus 2x to that side. So we'll have 2x is less than or equal to 7. Therefore x less than or equal to 3.5. And the same system for the bottom one. There are the three possible regions. Simplifying. Here we have the three regions, but be careful because of 1 minus x, it has the opposite effect. So in fact, the two critical values, negative 8 and 1, there's negative 8 to 1, above 1. But be careful, when x is less than negative 8, that's going to be negative, therefore a sign change, but that's going to be positive. So therefore it keeps the same sign. Between negative 8 and 1, this is now positive, that's it. This is still positive, so it just keeps the sign as it is. This one here, both positive, not that positive, that negative, sorry. That one is negative for greater than 1, 1 minus x, so therefore we have a sign change here. And simplifies. This one has four regions. negative half, naught, 1.5, three different critical values. So you have to consider the four regions.